that assignment over the surface area and lateral area of our pyramids and cones. Now we're going to find their volume. So the first thing we're going to need to do that is our formulas. Our formula for the volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. So B, remember, stands for area of the base. And H stands for the height of the pyramid. And remember, our height has to be perpendicular to the base, right? So we're using actual height, not slant height for this formula. All right, and then our formula for a cone. Our formula for volume of a cone is the same formula, 1/3 base area times height. But in a cone, we know our base is always what shape? Circle. So what do I plug in for capital B? Pi r squared. There we go. Times the height. And the only variable left to define here is r, which you guys know represents the radius of our circular base. All right, so we've got our formulas. Let's look at some examples over here. So on number 1, they give us this picture over here. We are going to find the volume of this cone. And we do know, because they marked this right angle here, that this is what we call a right cone or a regular cone because of that 90-degree angle. We know that's truly the height, right? It's not slanted like an oblique would have been. All right, so we just wrote down our formula for volume. Volume, we just said, was 1/3 pi r squared times height. All right. Okay, so we need an R and we need an H. Were we given both of those things? No, which one do we not have a value for? R. Okay, so I need to solve for R, which would be this piece right here. So what method could we maybe use to solve for R? Trig, right. So this is the angle that they gave us, right? R is adjacent, opposite, or hypotenuse? Adjacent. And the piece they gave us is the what side? Opposite. All right, so we have opposite and adjacent. Which trig do we want to use? Tangent, good. So tangent of the angle is equal to opposite over the adjacent, which is our radius. All right, so we want to solve for R. What are we going to do? Okay, so then I've got R times tangent of 65 equals 16. Then what? Right. So R is equal to 16 over tangent of 65, right? Okay, so we're going to keep it exact as long as we can. So I am going to use this for R in my equation. So we've got 1/3 pi r squared, and we just found out R is 16 over tangent of 65, and that's squared, right? Times the height, and what's the height of this? 16. All right. So, since the 16 and the tangent of 65 are supposed to be squared, we can't really simplify that middle section any until we go to type it in the calculator. But I could multiply my 16 and my 1/3, right? So I could write that as 16/3 pi times 16 over tangent of 65 squared. And this would be our exact volume. But if I want the estimate, I'm going to have to multiply by pi, and I'm going to have to type in that trig there. Make sure our calculator is in what mode? Degrees. Double check that you're in degree mode, and then you can type this in exactly as it's written here. Approximately, what do we get there?
We get 932.682.
Perfect. So 932.682, and what was our measurement here? Feet. So this would be feet cubed, and this would be our estimate answer. All right. Okay, so there's an example of our cone. Now let's look at example number 2, which is for a pyramid. So here, again, we're going to find its volume. All right, so this time, since it's a pyramid, we're using our first formula, which was volume is equal to 1/3 base area times height, right? Okay, well, what kind of base do we have here? A square. And what's our formula for area of a square? Perfect. So what is the area of this base? Good. All right. And do we know the height? No. Okay, so we're going to have to find that. In this little triangle down here, because this is a square, how long is that bottom piece there? 5. So this piece is 5. So what could we maybe do to find the height? Pythagorean theorem. Very good. All right, so we'll have 5 squared plus the height squared equals the slant height squared. Right? So this time we're looking for the A or the B, not the C. All right. So we've got 5 squared and 6 squared, and I'm going to have to subtract them to solve for h, right? What is 6 squared minus 5 squared? Good. So we end up with h squared equals 11. So h would be square root of 11. Good. All right, since there is no square root of 11, we'll keep it as this for now so that we can keep our answer as exact as possible. So I'll come over here and I'll have 1/3 times the area of the base times the height, which we just found to be square root of 11, right? All right, so if I want to keep this as exact as possible, I can multiply the 1/3 and the 100, but I'm not going to actually multiply by the square root of 11 if I'm keeping my answer exact. So my exact answer would be 100 over 3 square root of 11 feet cubed, right? As our exact answer. But if I'm going to give the estimate area, I can go ahead and multiply by that square root of 11. Approximately, what do we get there?
110.55.
Very good. And this is what we would consider as our estimate answer. All right, so whenever you get your assignment for today, I believe it actually says on here that they want you to keep your answers exact. Yes, all answers must be exact. So on all of these problems, you would stop right here. Okay, you don't have to actually type them into your calculator to get the decimal answer.